everyone. Welcome back. Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question. Please read it, pause the video, come back, and we'll do a nice cup. I like the design. Okay. In 1980, the world population was 4.44 billion people. A model created at the time predicted that this population would grow at a rate of 0.076 billion people each year after 1980. In 2015, the world population was 7.35 billion people. What is the positive difference in billions of people between the actual world's population in 2015 and the model's predicted world population in 2015? Okay, fine. So they want us to compare the actual answer, the actual reality, to what the model would predict. And the model predicts that it's 4.44 billion plus 0.076. I'll put billions per people. No, billion people per year. Billion people per year times number of years.
Yeah.
Seth, I should go to a smaller type font. Number of years. So now, how many years are there between 1980 and 2015? That sounds like 35, doesn't it? Because in 1980, it would be 0 years. In 1981, it would be 1 year. So we take the difference between these two, and that's the answer. So the answer to the question is the absolute value of the difference, 7.35 minus, and then 4.44 plus 35 times 0.076. And that is the answer to the question. Right?
Well, yeah.
And, that's the answer to the question. So then we have...
Okay. And please balance your parentheses.
Yes, thank you very much. I was just going to do that, but you beat me to it. So now this is a calculator question, which is nice. So you do, because they really want an answer. The only practical thing to do is to use a calculator here. They know you have a calculator, and they want you to use it. So, by the way, it went up by 2.66. So it went up by 2.66. So we add 4.44 to it. So it's 7.1. So this whole thing is actually 7.1. So it's 7.35 minus 7.1. You don't really need a calculator. It's a quarter. But you could use a calculator anyway. 0.25. So the answer would be 0.25. The final answer, 0.25. What I would do on the SAT is I would double check my work. It's easy enough just to maybe do it another way. 35 times 0.076 plus 4.44 is 7.1. Yeah, I would just double check the work. Seems like a relatively straight word problem that has a few different parts to it. You first have to calculate what the model would predict using a y equals mx plus b model, using a linear model. Oh yeah, linear model, right. Yeah, linear model. Using a linear model, the y equals mx plus b model. That gives you the prediction, which turns out to be 7.1. And then you compare it to the actual, 7.3. And they just want the positive difference. So you don't have to worry about which one is higher or lower.
Yeah.
Pretty straight problem. What do you think?
Yeah, pretty straightforward problem.
Yeah, pretty straightforward problem. So we can just go right into that. The question, one of the questions we always ask is, what was the goal of the test taker? what was the goal of the test maker committee? The test maker, not the test taker, the test maker committee. One is understanding how to apply linear growth or linear change, y equals mx plus b, or just a linear relationships, and also how to read and dissect a word problem, and how to also understand that when you want to compare two things, you subtract them. If you want to compare their difference, the difference, right? That means subtraction, not division. Not division. If they ask you what is the factor between two numbers, use division. But positive difference means subtraction. So there are a few things there that they want to see if you know how to do.
Yeah.
That's it. That's a multi-part word problem. So a lot of words.
Yeah,
Are there any patterns that are specific to this problem that one would take advantage of? I mean, no, I don't think so.
Yeah.
I don't think so.
They want the answer in as much precision as the data.
Yeah.
So you need to calculate. It's not a multiple choice.
Right. Yes, it's a free response.
Yeah.
That's right. So being that way, one of our questions we always ask is, can you back solve? Can you look at the answer and back solve? Well, obviously you can't because it's a free response.
Yeah.
Would this question be different from a question? Would you do this problem differently if it was on a school test? No. I mean, that's quite related to if there's a pattern that you could take advantage of. No, not really. And then calculator. Yeah, calculator definitely helps. This is a calculator set. This is a part of a calculator question. This is part of the whole test now is calculator. But the calculator definitely helps you in this situation.
Yeah.
That's it, right?
That's it. That's all it is.
That's all it is.
That's all, folks.
That's it. Okay. I guess we could just talk just for a second to get a sense of the just to get a sense of the question. It seemed like the linear model worked. And I don't know whether this is all just BS that they made up or whether this is really true, that the linear model actually worked. I mean, we just don't know. But you would think a linear model is not really how populations grow.
Yeah.
But maybe it is. Maybe it is. We don't know. We just don't know. We don't know enough about population growth. You could certainly Google that and find out whether this is a realistic model. But it seemed pretty close.
Well, the simplest model for population growth, with the simplest model based upon how living things reproduce is exponential.
Absolutely. That's why one has to call this into question.
However, then they complicate the model, make it more realistic when they account for limited resources.
Exactly.
Yeah.
Exactly. So anyway, now we're getting in an area we shouldn't be talking about, but it's always not a bad idea when you're studying for the test, not during the test, but when you're studying for the test, to just sort of look at the problem from different perspectives, because it gives you some depth of understanding, which you may need. Well, first of all, you should have that because you're going to be solving problems in the future. That's how you deal with things. That's how you deal with problems in real life. And also, you never know. Looking at different things from different points of view may actually help you on the SAT. So I guess that's it. I'm Joel. I have a PhD in mechanical engineering. My brother Seth's a PhD in math. We try to meet every weekday, to go over an SAT question and math question, to offer different approaches, to go over how to do it, go over the main idea, discuss different aspects of it. And so That's in terms of practicing for the SAT. Try to do as many practice questions as you can. The SAT is now digital, so go to this application called Blue Book. College Board will help you download it and do as many practice tests as possible. They give you 4, so you can only do 4. Learn from your mistakes, and if you're weak on any particular topic, go to Khan Academy, because they partner with the College Board and they have a list of all the topics that are on the test. And they have about 20 or 30 questions per topic, and you can just practice away, get good at what you're not so good at, learn where you're making your stupid mistakes, and just practice. That's about it, right?
That's about it.
That's about it for today. Good, short and
That's
relatively all. For us, short and sweet. And please leave us comments on our YouTube videos. We take all the comments seriously, and if you have any SAT math questions, then please email them to us at satmathquestionoftheday@gmail.com. Okay, everyone, have a great day.